Let's see another problem from LeetCode. It's a medium level problem. It's the longest common sequence. Let's try to understand this problem, and then we'll discuss the logic how to solve this. So there is a text 1 and the text 2, and we need to find out the longest, the common subsequence, like that subsequence should be in this string and also in a text 2 also, and that we need to find out. And for the longest subsequence of the string, for that I have already created the video for that, so you can go and watch that video and you will get some idea. But this today the algorithm what we are going to use, that's a little bit different, but it's not a tough, I can say. So from here, if you see in this two string like ACE, like A and CE, this is a subsequence ACE, and that's also ACE is here, and that is the longest subsequence that is the common in both text, and that we want to return here. And if you see like subsequence, there can be the A, B, C, D, E, that can also be the subsequence, but that is not here in a text 2, so we cannot consider that. But we need to choose the subsequence that is longest subsequence that is common in both. So one of the way we can think is like find all the possible subsequence here and all the possible subsequence from here, and then we can find the common one, and then we can see like which one is the longest. But that is that is not a very efficient way, so we want to use the different approach. So let me move to some other screen and we understand what will be the strategy, and then after that we can write the code. So let's say there is a ABC and ABC. So in this case we are going to use the recursion, and we'll start from here, from the end, and we'll see okay both are same, then okay we found one, this is same, we found one, another one, and this is same again, we found another one. And in this way we can call the recursion on both a string, and we'll check the last character in the both of a string. If both are same, then we just increment the counter, and in this way we know that okay that is the max the common sequence that's present in both the string. In the case of the another example, let's say CC match, and then here C, and maybe here D, something like this. Like if it doesn't match, so if it doesn't match, then what we'll do, CC this match, but C and D doesn't match. So in the case if it doesn't match, then we'll try other option, like maybe we can just try that okay we can stick here, and we can try with other option like CC match, then that's fine, we can move here and we can move here because both matches. And from here now we need to find out like which is matching or not. So in this case CD it doesn't match, so we can fix this C and we can check with A, so that's matches or not. Or sometimes like we can fix this and we can check this one, and if it matches, then we can find the max of that one. So that's the formula we are going to use. So let's write the code and we'll get some again the better idea from here. So I will call this longest common subsequence here, and let me call this function like, let's say this is S1 and S2, and let's make this name the helper. So it's the helper, and the index is, it's a last index we can pass. So the length of text1 -1, and the length of text2 and -1. So you send the last index here. Let's write this function, and whatever it returns, that's we are going to return, and that's our answer. So I'll call this function func, and both our type is a string, so, and both of this type is int. And I can say that's in I and j, and that's the index, and return int. And like when we check, like first we check like if I can say s1 s1.i is equal to s2.i, if both are equal, then in that case we can add 1, return 1 plus, and this function again. So it will, if the last character, both characters same, then move to the that's the one found, and then again we recursively call the same function. So internally keep going there. So call this function, and then we can pass s1 and s2, and in this time I -1 j -1, and whatever it returns, that's the answer. In the case if it is not equal, then in that case we can try, we cannot add this one, but we can in a one string we can move further, and another string we can be in the same position, and we can try with other character if they're same or not, and we need to find the max of that. So let me create one function, max ab int, if a greater than b, return a, otherwise return b. So I will call the same function here, plus this one, but this time when we check for s1 s2 I, we can fix the I, and then check with a next character in a second string, and then also we'll try other combination. We can fix j, and we check the other character in the first string, and we can find the max of this, and we can return that. So max of this, and we can return. So that this is the logic. Let's run this. Okay, we need the base condition. So when we keep moving I -1 and j -1, then sometime it will reach to 0, less than 0. So if I less than 0 or j less than 0, then in that case we can return 0. That's the base condition. Line 3, that's the helper, undefined s1. So this is not the s1, but this is the text1, and this is text2. Not enough arguments. We pass longest common sequence helper. Why? Okay, not enough arguments in a call max. So in a max, yeah, this will return int. So that's the one int, and then this will also return int. So ab int, have int, and want int. So this may be some bracket issue. Let's check this bracket. So that's okay. j minus 1, and then it's a s1 s2 I minus 1 j. So let me call in another way and say result 1 and call this here result 2, and oh, okay, now I got it. That is the plus in between, we put that, that's the reason. Go back, and here just give the comma, and let's try once again. Is ij, so from the I and j we pass length of I and j. So what about we do the s2 I, and this should be j. Okay, accepted and submit. Okay, for the time limit exceeded, so we'll use the memoization. So but yeah, just try to understand this logic here. S1 is checking the last character same, then we found one result, and then we'll move both strings, we'll move one character, and then we'll check another string. If the string is not same, then we'll fix one one string will fix the character, and another string we'll move that. So in that way we'll check this, and then we'll find the max of both, and then we can return the result. But for the memoization, when we go to the recursion, we have already calculated some of the solution, and we want to return that. So for that, let me use memoization here. So for that, I will use one ds, I can say, or ds data structure, or dp, I can just say it's a map, and it's a make string, and then value will be int, and we can pass this dp here, map of a string, and we can pass the dp, and here also. And when we get this result, we can store this result in a map. So here the for the variable, if you see the I and j, these two variables are getting changed. So in that case we need to create the key based on this ij. So let me create the key here. Key is empty printf, and then %d hyphen %d, and we can give the I and j here, and that's our key. And we got the result in this place, and here also. So store this result in a result variable, and we can return the result, and before returning we can store this in a dp. So dp key, we have already created the key, and the value will be result. And same thing we can do here also. So that's also a result, you can see here, and I can return the result and store the result in a dp key. And if you find this result, then we can return the result. Will not do the further recursion. We have done this kind of memoization in many other programs, so you can check that also. I'm just checking in a map, so our dp, and inside the dp I'm checking the key, and if that exists, v and ok, I can put if logic here and ok, then return v. Otherwise we can go and do the other recursion. So that's the logic. Let's run this and check. It's accepted, submit, Okay, so that's all for now. In the next video I will try to write this program using a DP array. So that's all for today. Thank you.